Warahmatullahi Ta'ala Wabarakatuh, and good day everyone. Okay, so today is our very first asynchronous lecture, our first lecture as well for this course, Engineering Maths 2, EDI3023. Okay, we're going to begin our chapter 1 topic, eigenvalues problems. Okay, so for your information, and I'm sure all of you are aware, I have uploaded 2 parts of notes for this chapter, part 1 and part 2 at your e-learn. Alright, so for today, we are going to start first with the part 1. Okay, part 1 here cover introduction to eigenvalue problems and eigenvalues and eigenvectors. So I'm sure to all of you today, what is this? Eigenvalues, eigenvectors, maybe very minimal of you who ever heard about this before. Same to me before pun. Okay, eigenvalues, eigenvector. During our last class, I was saying that chapter 1 ni closely related with matrices, but how come you can't see any kind of matrix? Oh, ada kat bawah ni je. Okay, number over here je ada perkataan matrix kat sini kan. Okay, other than that you couldn't find anywhere the word matrix, but how come it is closely related to matrices, as I said before in our overview class? Okay, that is what you are going to find out in our today's class. Okay, so the learning outcome for today is, first, make sure you faham apa maksud eigenvalue problem, apa maksud dia, and the second one is how to find the eigenvalues and the eigenvectors. Okay, so make sure everyone at the end of this asynchronous lecture, within maybe 3 or 4 series of short video that I'm going to share with all of you, you are able to determine the eigenvalues and eigenvectors. Okay, and the remaining topic is what we are going to discuss in our upcoming classes. Alright. Okay, so for an introduction, to let you understand why it is important for us to study about these eigenvalue problems. Okay, let us consider an example. Okay, let us consider an example. Okay, let us consider an example here. Let's say kita ada a matrix, a simple matrix. Okay, let's say we have a simple matrix. This is where the matrix comes to the story lah. Okay, we have a simple matrix. Let's say we have a matrix 1, 2, 3, 4, just like this. Okay, matrix 1, 2, 3, 4. And I'm asking you to find a power of 2. Apa maksudnya tu? Okay, a power of 2. Based on what have we learned in Engineering Maths 1, does that mean a power of 2 is equals to 1 square, 2 square, 3 square, 4 square? Then you will get 1, 4, 9, 16 macam ni. Is that correct? No, this is not algebra, right? Because this, what we're talking now is about the matrices. Okay, it's about the matrices. Okay, so what is the correct way for us to find a square? Okay, based on what have we learned in Engineering Maths 1 as well, dalam topik matrix, to find a square is actually A, matrix A times with matrix A. Am I right? Okay, so maknanya kat sini, tadi saya kata matrix A kita adalah 1, 2, 3, 4. Okay, and you are to multiply with the same matrix 1, 2, 3, 4. Okay, so daripada sini, bila kita nak multiply these two matrices together, this is just a revision to all of you, macam mana kita nak darab dua matrix together ni. Okay, 1 darab 1 tambah 2 darab 3, betul tak? Then we get 1 darab 1 tambah 2 darab 3, 2 darab 3, 6. 1 tambah 6 is 7. Then you proceed lah untuk next element. First row, second column, second row, first column, second row, second column, and until you get all the element. I'm not going to do that now. Okay, so that is A square. Kan, kita akan dapatlah A square, such a value nanti. Alright, so if in case the question asks you for A power of 3, apa yang you perlu buat? See, based on apa yang kita dah belajar sebelum ni, next, kalau kita nak cari A power of 3 pula, okay, if you want to find A power of 3, then meaning to say, you kena buat, kita dah dapat jawapan A square tadi kan, then you have to multiply with another A, right? So, whatever value that we have for A square tu, then you are to multiply with matrix A 1, 2, 3, 4 balik, okay? And the process will repeat. Katakanlah A power of 4. Kalau A power of 4 maknanya you kena darab A power of 3 darab A. Dan you dapat A power of 4. Betul tak? Maknanya A darab A darab A darab A darab A. Okay, kalau A square tadi, it's not a big deal. A kuasa 3, okay lah, boleh lah. A kuasa 4, dah start merungut kan? What if the question asks you for A power of 100? Oh, ada tak calculator? You akan pandai cari calculator online dekat internet tu kan, yang boleh cari sampai A up to 100. Maybe ada, and you are able to come up with the answer. But again, as I say, okay, kita tak nak tahu jawapan, but we want to know the journey. How do you get the answer? Okay, so to get such a thing like this is where we need this eigenvalue problems ni, how to solve this kind of problem dengan apabila kita berjaya dapat eigenvalues and also the eigenvectors, we are able to solve A up to power of 100 ataupun 1000, okay, as long as you are able to find the eigenvalue of the matrix. This is where does the eigen story begins. Okay, so maknanya kat sini you all, for every matrix it's supposed to have its eigenvalues. Alright, hopefully everyone are able to understand this. Okay, every matrix is supposed to have its eigenvalues, yang mana bila kita ada eigenvalues, we are able to find its eigenvectors, dan daripada eigenvectors itulah ianya mampu untuk menyelesaikan masalah kalau kita nak cari, let's say, a matrix A to the power of 100 for an example. Okay, boleh faham kenapa kita perlu tahu macam mana nak cari eigenvalue and eigenvectors. Okay, up to now, it's enough for you to understand every matrix, or specifically every square matrix. Apa maksud square matrix? When number of rows sama dengan number of column kan. Every square matrix will have its even value, kecuali there are certain conditions where we are going to discuss later. Bila ada eigenvalues, then we are able to find its eigenvectors. You boleh analoginya, you boleh samakan dengan an inverse of a matrix lah. By right, every square matrix has its inverse. Macam tu. Everyone dah tahu kan apa maksud inverse. Dengan adanya inverse, kita boleh guna inverse tu, or we utilize the inverse to find the unknown variables. Betul tak? Macam ni jugalah eigenvector, eigenvalue ni, bila kita tahu eigenvalue and eigenvector, we can utilize them untuk cari whatever, untuk solve whatever problem that we have. Okay? Alright. Okay, so next, okay, kita akan discuss on how to find, kita akan discuss, we are on the way on how to find the eigenvalue and eigenvectors. Alright, so kita ada a matrix A. Let us consider we have a square matrix A, okay, n times n. Tak kisahlah number of row berapa, number of column berapa. And we have another matrix X, okay, where this matrix X is just consists of n row times with one column. Okay, n row times with 1 column. Katakanlah kita ada matrix, okay lah, nak tunjuk kat you all ni, matrix A, okay, 1, 2, 3, 4. Saya guna je 1, 2, 3, 4 ni. So a matrix X ni, saya katakanlah matrix X ni, kita kata kita ada X1 and X2. So this is our matrix X. Okay, and this is matrix A, where our matrix A is 2 times 2 matrix. Okay. So, apa yang dia kata, a matrix A darab dengan matrix X ni, dia akan menghasilkan A times with X is equals to lambda times with X. Okay, so this lambda ni adalah is what we call as eigenvalues. Tak apa, you terima je dulu cerita ni. Nanti through example, I'm sure you are able to understand better. Okay, this is what we call as eigenvalues. So what is the relation between matrix A with the matrix X and eigenvalue adalah matrix A darab dengan matrix X is equals to the eigenvalues multiply with matrix X as well. So matrix X ni apa? Matrix X ni lah yang kita kata sebagai eigenvector. Okay, matrix X ni dah adalah kita punya eigenvector. And what is this lambda? Lambda ni adalah our eigenvalues. So which one comes first? Yang mana kita boleh cari dulu? Eigenvalue ke eigenvector? For your information, kita boleh cari eigenvalue first. From where? From our matrix A. From our matrix A. Okay, apa maksud ayat ni? Sabar dulu. If I explain now pun you tak berapa agak susah untuk you faham. Is to seek non-trivial solution ni, apa maksud dia ni? We'll go through an example so that easier for you to understand. As of now, you just faham the relation between matrix A with the eigenvectors, where A darab dengan eigenvectors is equals to the eigenvalue darab dengan eigenvector. How to get this eigenvalue is what we are going to discover next. This eigenvalue can be found using matrix A ni. For every matrix A by right, it has its eigenvalue, dan daripada eigenvalue ni we are able to come out with the eigenvector. So that we are finally we are able to show that A darab dengan eigenvector is equals to lambda or eigenvalue darab dengan eigenvector. Okay? Okay, let's begin with this example 1. Tapi example 1 ni kita belum lagi nak cari how to find the eigenvalue, but it's just to show. Okay, it's given to you already the answer, where show that the eigenvector 2, 1 here, which is we have 2 rows times 1 column, is an eigenvector for matrix A. So matrix A kita adalah 2, -4, 3, -6. So how to show that it is an eigenvector for a matrix A? Remember the relation just now. Matrix A darab dengan eigenvector, dia sepatutnya dapat eigenvalue darab dengan eigenvector, kan? Alright. So what we have, kita ada A, kita ada X. We have no choice. Kita cuba je lah darab A darab dengan X. So we try to multiply matrix A, 2, -4, 3, -6, multiply with 2, 1, and we'll see what happened. Okay, this is A times with X. Okay, let's find out what is going to happen. 2 darab dengan 2 is 4. -4 darab dengan 1, betul? So, dia akan dapat 4 tolak 4. Okay, and the next one is 3 times with 2 is 6. Second row times dengan with the entry or the first column, first row for the second vector. So, dapat 6. -6 darab dengan 1 yang ni, get -6. So, what you will get here, surprisingly, kita akan dapat 0, 0. So, apa maksudnya ni? Okay, maksudnya ni adalah 0, 0 ni, which is A times with X, is actually our lambda times with our matrix X. So our matrix X or the eigenvector just now is 2 and 1. So benda ni dia akan jadi sama dengan kosong kosong. What does that mean? Ni maksudnya apa yang menyebabkan this part become 0? Okay, this part will become 0 kalau our lambda ni is equals to 0. Okay, is equals to 0. So, dia punya conclusion here is 2, 1 is an eigenvector for matrix A if, dia ada if dia, lambda is equals to 0. If lambda equals to 0. Kenapa lambda perlu equals to 0? Because it must satisfy this condition. A times with X must equals to lambda times with X. Okay? Boleh faham Alright, so we're going to stop here for the first part of the video for today's asynchronous lecture. In the next video, barulah kita akan belajar how to find eigenvalue if it is given to you a matrix A. Alright, see you in the next video.